Here in the I button and in description box below, you will get the complete playlist of multiple integrals. Welcome to video number 5. Welcome to video number 6, in which we are going to solve fifth problem on the topic, that is double integrals. If you go to the playlist, you will see in double integral topic we have solved these important problems. And in this particular video, we are going to solve this fifth problem, which is very important. So let us start. The question says, evaluate double integral xy x plus y dx dy over the area between y equals to x square and y equals to x. Here we have y equals to x square and y equals to x. Looking at this, we can say this is an equation of a line, and this is an equation of parabola. Equation of parabola. But here we can see the power of x is even. So since the power of x is even, so we can say that this parabola is symmetric about y-axis. Okay, so we can say symmetric about y-axis. These are very crucial point regarding these two equations. Okay, so like starting with the, that is, evaluate this double integral xy x plus y dy dx dy over the area between parabola and line. So here we will first draw a parabola, then a line. This is a parabola whose equation is given as y equals to x square. And suppose this is a line whose equation is y equals to x. Okay, this is a line whose equation is y equals to x. Fine. Now we can see this is the common area. So suppose I am taking a strip which is parallel to y-axis. That is, we are considering vertical strip. I am taking vertical strip. You can take vertical strip or horizontal strip. The answer will be same. Okay. So going forward, here we can see the intersection point of this line and curve are this point and this point. This point is clearly, that is origin, that is 0 comma 0, but we have to find this point. Okay, that is x coordinate and y coordinate. For that we have that is these two equations, that is y equals to x square and y equals to x. Suppose this is my equation 1 and this is my equation 2. On solving both the equations, you will get, in place of y we can put x because y equals to x. So we can say x square equals to x. Solving, that is x square, taking this x to the left hand side, this will become x square minus x equal to 0. Again solving this, you will get x common, x minus 1, that is equal to 0. From here you will get x equals to 0 and x equals to 1. Okay. Now if you put x equal to 0 in equation number 2, you will get y equal to 0. Similarly, if you put x equals to 1 in equation number 2, you will get y equals to 1. So we can say when x equal to 0 implies y equals to 0, and when x equals to 1, y equals to 1 from equation 2. Okay, so we can say the intersection points are 0 comma 0 and 1 comma 1, because when the value of x is 1, y equals to 1. So here we can say, hence the intersection points are 0 comma 0 and 1 comma 1. Okay, now we will start solving this double integral, that is double integral x y x plus y dx dy. Now here you can see the strip is parallel to y-axis. Why? Because we have considered this vertical axis. Since this strip is vertical, which is parallel to y-axis, so first here, okay, here we need to write limits of y. Okay, here we will put the limits of y. If now here you can see this is my vertical strip whose base is on the curve, that is y equals to x square. So here the lower limit will be x square, because we are taking here, this is the limit of y, and the lower limit is y equals to x square, which because this is on the curve, that is parabola, whose equation is y equals to x square. So this is lower limit will be x square and upper limit will be y equals to x, that is line. Okay, here the upper limit is on the line whose equation y equal to x square, and lower limit is on the curve whose equation is y equal to x square. So lower limit will be lower limit will be x square and upper limit will be x. So here we can see the limit of y goes from x square to x. Similarly, if we take limit of x, that means we are going from this to this. Here the value of x is 0 and here the value of x is 1. So we can say the limit of x goes from 0 to 1. Now a very important thing, that is, since this is the limit of y, so first we have to write dy, because we have to integrate this function with respect to y. So we need to change this order. So we can rewrite this as integration 0 to 1 integration x square to x. We can open this bracket, that is x square y plus x y square. Now changing this order, that is dy dx. First we will solve this first part. Okay, so keep solving 0 to 1 integrating with respect to y. So this is going to be x square y square upon 2 plus x y cube upon 3. Limit goes from x square to x. Don't forget to write this dx. Now again we can put limits in place of y, because we have integrated with respect to y, and this limit, that is x square to x, is limit of y. So integration 0 to 1, here we can write, that is this x square upon 2 is as it is. Y will change, that is this is going to be x square, okay, minus writing this again, that is x square upon 2 in place of, yes, now lower limit, that is in place of y we need to put x square, but here we have y square, so this is going to be x to power 4. Yes, this is the limit of first term. Now coming to second term, plus x upon 3. In place of y we need to put upper limit, that is x, so this is going to be x cube minus x upon 3. In place of y we need to put x square, so this is going to be x to power 6. Again closing this bracket. This bracket is for this bracket is for this, and this bracket is for this, and at the last we need to write dx. Don't forget to write this dx. Now yes, this is going to be limit 0 to 1. This will be x to the power 4 upon 2 minus x to the power 6 upon 2 plus x to the power 4 upon 3 minus x to the power 7 upon 3 dx. Now we can integrate with respect to x. So this is going to be x to the power 5 upon 10 minus x to the power 7 upon 14 plus x to the power 5 upon 15 minus x to the power 8 upon 8 into 3, that is 24. Okay, limit goes from 0 to 1. On putting the limits, upper limit is 1, that is 1 upon 10 minus 1 upon 14 plus 1 upon 15 minus 1 upon 24. Ignoring this second lower limit because that is 0. So this is going to be, now taking LCM, we are taking LCM for these two terms, that is how much? 70. Okay, 70. Then this will be 7 minus 5. For the similarly, LCM of these two terms will be 120. Okay, now here it will be 8 minus 5. Now again, this will be 2 upon 70. So 2 upon 70 is 1 upon 35. This is 1 upon 35 plus this will be 3 upon 120. 3 upon 120 means 1 upon 40. Now solving this, we are taking LCM again, that is 35 into 40. So here it will be 40 plus 35. Now again adding both, you will get 75 upon 35 into 40. Now simplifying, that is dividing by 5, this will be 15, this will be 8, again this will be 7, this will be 3. So this is 3 upon 7 into 8, that is 56, and this is my final answer. Okay, thank you so much.